Now listen attentively. This example theory for projectile. But if you have studied projectile with your conventional textbooks, you would have been able to solve this question. That's because for those projectile, they simply gave some formulas to deal with projectiles, such as maximum height, range, time of flight, time to maximum height, and maximum range. And none of those formulas could solve this question. So many students missed this question in 2022. That's why I often emphasize that use of the equation of motion to solve any type of motion, be it projectile or not projectile. And that's why you need to go through our video on projectile or other type of motion, such as horizontal, vertical, or horizontally projected motion. That would help you comprehend motion perfectly and know how to solve any motion. So we'll be solving this question with normal equation of motion. But now pay close attention. Let's look at this question. The diagram above illustrates the trajectory of a fired missile from point P at 250 meters per second. If the missile hits point Q after 40 seconds, calculate the distance PQ. So we required here is distance PQ, which you can call the range. We are given the time taken to get to PQ, which is 40 seconds. Now, to solve this question, we just need to say that x is equal to uxt plus half at squared. X means horizontal distance, and that's it here, from P to Q. Again, is that we can say this x is what we also call range, which is your PQ. Take note of that. Now, take note that if an object is projected, A is 0. If you've gone through our motion, you would have heard that over and over again. If an object is shown, especially our horizontally projected motion, if an object is shown, it does not accelerate. And I often say this, that acceleration means increase in speed. If you throw an object, it doesn't just start moving. You see, it just cannot just start increasing. If you throw it slowly, it lands to wherever you throw it slowly as well. And if you throw it fastly, it also lands. That's because a thrown object cannot accelerate. Now, we have that our ux. Let's get our ux. Now, to get ux, you don't have to resolve this horizontally. So here, but ux will simply be 250 cos 25, cos 42. 250 cos 42 degree. Now, if you don't know how to resolve, you seem to go and watch our video on resolution. I will drop all of these videos on the description of this video, so you can watch it. Now, what to do here is to say 250 cos 42. Let's evaluate that now. 250 cos 42. That is 185.79 meter per second. Now, the next thing we need to do is to remember that since A is 0, everything here is gone. So we're left with the range of PQ being x is equal to ux times t. Now, what's your ux? 185.79 times, what's the time? 40 seconds. And then we can get this. That is 185.79 times 40. And that's 7841.6 meters. Now, what students did for this exam, which is wrong, this is the right solution, is that they went to solve that range is equal to u squared sine 2 theta over g. Well, if you use this, you'll be wrong. And that's because there's no way to even put your time, 40 seconds. And some still went ahead to assume that the time for this question is just given for giving sake. It's just given to confuse the student. No, the time ought actually to be there. But you can't use this equation because there's nowhere to put your time. And they quickly did. The range is the PQ. And they said U is 250 squared sine 2 times 42 over 10. If you do this, you would actually be wrong. And let me tell you what you would have. we have 6215.76 meters, and that is actually wrong. And so that's why I will often say that equation of motion can solve every type of question, be it a projectile, be it an horizontally projected motion, be it an horizontal motion, and be it a vertical motion. And all of these things, we treated them well in our video. So do well to watch those videos, like, share, and also subscribe.